In this special tutorial by the Learn It channel, you will learn the steps needed to take a project from an idea to completed part. We will discuss what's needed to research something, how to plan out a project, sketch and model the part, create a technical drawing, order the part with confidence that it will turn out as intended, and then see the final product. Welcome to the Learn It channel. Let's make an old school safety razor. So welcome to a special tutorial as brought to you by the Learn It channel. Today we're going to be talking about the thought process, the design process of a safety razor. So if you don't know what a safety razor is, it's actually kind of an old school, an old style way of shaving. And for me, I've been using safety razors for about 15 years now. Before that, I used standard razors that you buy at the store, and they're a fortune now. They're so expensive. Now that I have this YouTube channel, a lot of the tutorials that we have so far, as you're very well aware, they talk about just simple parts. And I thought, how cool would this be to create a safety razor, create the three main components for it, show everyone out there how to go about the design process, problems that we run into, situations that we run into that we have to fix or we have to think ahead of in order to make a product that actually works. So the goal of this is we're going to have 3 episodes. We're going to use each episode to talk about an individual component. And then what we're going to do is create the drawing, because we'll need a technical drawing for that. And lastly, we're actually going to get these parts ordered. So anyone out there who's been following our channel a little bit, I've been working in a machine shop since the age of 12. I worked for my dad for many years, but currently I don't have a machine shop at my disposal. So I'm actually going to be ordering this on PCBWay, and we'll get to that in a little bit. But basically it's a website where you can order 3D printed parts, you can order CNC'd parts, and I'd like to order each individual component. And by the 3rd episode of this series of tutorials, I'd like to show you the actual final assembly, and hopefully I'll actually be able to shave with it. I don't know, but let's have some fun. At least along the way, you can see my thought process on how we can actually design this. And if there are engineers out there and you see along the way that I've made mistakes, please let me know. I would love to be able to learn from you. But at least you can kind of get the general scope and hopefully be able to use some of the skills for your own project. So let's get into it. First of all, I'm going to save this, and we're just going to call it our safety razor assembly. Great. Okay, so the first component that we're going to create is the razor. I'm going to show you in a moment here. We'll create the razor blade first. And you can see here, one of the new features on Fusion is that there's an anchor right there. It's anchoring this part or this component to its parent. And in this case, the parent is our top level component, or in this case, it's an assembly. But anyways, as we create our components down the list here, we're going to have the top, we're going to have the bottom, we're going to have the handle. We're going to keep the razor stationary. That's going to be grounded the whole time. So I'd like to just show you where I'm getting my information for the dimensions for this razor blade. I did a lot of searching and I found one. I'll just show it on the screen right now. This has all the dimensions in metric, so we're going to have to make sure our document settings is set to metric. And I'm going to be working within these specifications, and I'm going to hope that they're going to be right. I've measured some of my blades that I have in my possession, and they match up. So I'm hoping that everything's going to work out. But take a screenshot of this. You can also get the link in the description below. But I won't be showing it on the screen. I'll just be working with it. I have a second monitor that I'm working with those dimensions right now. So what we're going to do is we're going to create a sketch, and I'm going to create this on the XZ plane. Now, first and foremost, we are going to create a spline, a fit point spline. We're going to mirror it down the y-axis, and I call this y because this is a Cartesian plane we're working with right now. It has nothing to do with our 3D model. As explained in many of my other tutorials, our sketch plane is different than our 3D model. Our sketch plane will always have a y-axis running up and down and an x-axis running left and right. So what we're going to do is we are going to start here. Let me just make sure, is this in metric? No, it's in inches. Okay, so let's just change that real quick here. Go to the document settings, click right there, and we're going to switch this to millimeter. Okay, so let's go back to our spline, and as we look at our drawing, we can see that our dimension, our A value is, it has a maximum and minimum. It has a tolerance to work within, but I'm going to just specify right in the middle around 22 millimeters, but we're only working with half because we're going to mirror it off of our y-axis. So let's just create a single line with our spline. And here we have these control handles in green, one on either side. And what I'm going to do is we're going to know that with this particular blade, it's going to be bent within the handle, something like that. But we're going to have to create some parameters so that we can control this. So let's do that real quick. We're going to go to our modify dropdown and change parameters. I like clicking on the three dots here and pinning it to the toolbar. You can also pin it to shortcuts. Shortcuts is when you press the S key on your keyboard. There you have it. You've got these shortcuts that come up, and there is our parameters. So we can just do that as well. Very good. Okay, so let's just click here, and we're going to call it our razor Y. Great, and I don't know what this is going to be. I'm just going to call it 10 for now, and we're going to call this our razor X. Okay, so we've got two values here, and I'm just going to go 20 just for fun of it. And we're going to press D for dimension. And let's click on our origin and then our endpoint. So what value is this going to be? We're going to call this our razor X. Very good. And you can see it's going a little bit wonky right now, but we're going to create another dimension right here. And this is going to be our razor Y. So this is just something that we can control our spline a little bit more. Now, what we have to do in order to adjust our spline, or we need to know the total length actually. And here the length is 22 mil. Now the total length of our razor is 22 mils. So we have to make this value, when we click on any entity, you'll see that the total length of it is 22 mils. We can't specify the length of a spline. We have to look at the length using this method. We can always do it with inspect as well. This shows us the length, but I find just clicking on it here and looking at it in the bottom is the easiest way. But we also have to control a couple other things. First of all, I want my control handle here to be perfectly tangent to the other side. So how do we do that? Well, let's just single click our control rod, and we're going to click on the horizontal vertical. So no matter what I do with this control handle, I can move it. Oh, let's grab this here. Oh boy, now it's going crazy. So Control or Command Z will make it so that we can adjust. But you can see now, no matter what I do with this control handle, it's going to keep this control handle completely horizontal, which means it will be perfectly tangent when we mirror it. So now, again, this is way too long. This is 23 mil. So I'm going to go back to my parameters, and we're going to change some of these things. First of all, in Y, let's just go 5 mils right there. And now you can see that this rod is a little bit too much. If it's beyond 45 degrees, then the spline is going to be going above our x-axis, and that doesn't look proper at all. Anyways, so we're going to just adjust this. We could also put tolerances on our control rods here as well. But basically at this point, we're just clicking on this to make sure that we're going to bring this down to 11 mil. So obviously we're going to need to adjust this. Let's go back to our parameters and change from 20 to 10. And let's see what we have here. So this is getting close to our 11 mil spec that we'd like. Let's just grab our dimensions and bring them a little bit closer. That way when we press fit, or down here, F6 is the shortcut, that it will fit everything in there. If we have our dimension way off into space over here, this is 16 feet tall right there, and then we go fit, well, it's going to fit our dimension within our window. So we want to bring our dimension down here. Now we press fit, and now it makes everything look good and nice and good. Now this control rod is probably a little bit long as well. It's trying to fit that as well. Anyways, let's go back to our parameters. We're going to change our razor Y. Let's just go to 2 mils. And now let's see. This is the cross section of our razor. We're going to click on that. This is 10.38. I'm going to make this control rod a little bit less. Trying to picture or imagine what the razor is actually going to do. This I can probably bring, let's bring out right there. So it's going to follow that path. The point is going to be here. If you can't follow, just keep on watching. You'll understand what's happening later on. But I think something just along those lines. Now, this is 10.257. Very good. So we need to make it just a little bit longer. So let's bring this to, let's go to 10.5. And again, we're going to see what this is like. Yeah, we've got to bring it right to 11 mils. So let's just bring this out, the 250 as well. Let's go to 7.5 there. And we're just going to keep on measuring. Again, with splines, it's a little bit annoying because you have to kind of go back and forth. You kind of have to juggle it in order to make sure that it's just right. So there we go, 10.985. Let's just bring this out to 65, and it should be pretty close. Right on 11. Okay, perfect. So this is looking great. The only thing that we can change at this point to adjust the shape of our spline are the control rods. So this is the only time, the only time that I would encourage you to right click, and we are going to fix unfix. So remember, try and never use this. The only reason I'm using this again right now is to not have to constrain my control rods. That's what's going to turn our spline black. Anyways, let's go finish sketch. And we've got our blade right here. Perfect. Actually, let's go back to our sketch. Now we can mirror it. Remember, we need a mirror line. So let's just create that. I can even single click and press X. Very good. And that will change my line into a construction line. We can mirror it right now. There we go. Mirror line is going to be right there. Perfect. So I've got this shape, and this is going to be kind of just what our blade is going to look like. Now let's finish our sketch. Okay, very good. And what we're going to do is go to extrude. Remember, with type here, if we just go to regular extrude, it needs to be a closed profile. But we don't have a closed profile. We just have 2 splines, or 1 continuous spline right here. So we need to go to thin extrude, and we need to pick those 2 lines. And now at this point, we can extrude it. So let's extrude it symmetrically. We can pull this out, and we need to adjust a couple things here. So our thickness is actually 5 thou of an inch. So that's the thickness of a human hair. We're going to call it 5 thou, and IN. That will turn it into actual inches. And our distance, as we can see in our reference, is B plus K, and we're going to multiply those together. So let's go to closed bracket, or open bracket, I should say, 18.5 plus 2.2, and we're going to close that, and we're going to go multiply by 2. So this is the half measurement right now. We don't want the half measurement. We want the whole length. This is the exact measurement that we see right here, our total length, and it's at 41.4. Yeah, that looks good. Perfect. Let's go OK. Now we've got ourselves kind of, again, what the shape of our blade is going to look like. Now, if we wanted to just polish it up a little bit, we could, let's do it. Let's go to modify. We're going to go chamfer, and I'm going to pick this edge, and let's go to distances. Remember, we know that it's 5 thou total thickness. If I select this bottom edge, I'll probably get an alarm right now. Let's just see if we bring this down. Yeah. So what we need to do is remove this edge. We're going to press Command and click on that. but we can pick the opposite edge over here. And now that should retain our adjustments or our dimensions. So we're going to pull this down. This one is going to be 0.0025 inches. And our arrow, I don't know how long this is, so we're just going to call it 1 mil. Yeah, let's call it 1 mil. Well, yeah, 1 mil sounds good. I don't know what it's actually supposed to be. It doesn't say it on the drawing itself. So we're just going to do that. We're going to repeat it. Remember, right click and we can repeat chamfer right there. I'm going to pick the other edges on the bottom and we're going to do just the exact same thing. So let's pull this up here and 2.5 inches. Perfect. And move this over 1 mil. Okay, so it's not letting me right now. Two distances. Let's see what's happening here. Okay, so it's not letting me go to the full 1 mil length, but that's okay. Let's just do that. So this is again kind of the side profile. I'm not trying to make the razor look pretty. I just like to use this as a reference so that I can work with it. Anyways, so hopefully this makes sense. We've got the basic shape of our razor, and now we're going to start creating our other components. So let's create our first component. We're going to do that in a moment. Let's go back to our razor first of all. And remember, we've got this profile of our razor, the side profile, but if we were to, use this offset right over here, we could probably put in the offset, the complete outer limits of our razor, but I don't want to do that. I do want this geometry though. So we're going to finish our sketch, and now under our safety razor assembly, I'm going to activate that, and I'm actually going to create my sketch for the top and the bottom components of the safety razor, the head and the body, you might say, and I'm going to create that underneath our assembly rather than within the individual components. So instead of right-clicking and creating a new component, calling that top, creating a sketch within that, I'm going to create kind of what's referred to as a master sketch. And within that master sketch, you'll see how we're going to utilize it in order to create components based off of that sketch. So anyways, let's just get into it. I'm going to create a sketch. I'm going to create it on this plane right there. And now what I'm going to do is I'm going to project this body. So press B. Let's get our body here. We're going to project that and we're going to hide our razor. So now we've got this projected outline, and these dimensions are what I'm going to start working with. And again, this is not perfect, exactly the perfect shape of our razor, but the upper and the lower profiles or edges or splines we're going to use in order to create our pinch points and to make sure that our razor blade can fit within the parameters of our top, our top and our body of our safety razor. So let's do this. Let's create our complete profile first of all. And again, I'm just going to try and experiment with some dimensions here and adjust it in the future if need be. So I'm going to let's go 3 mils this way. And we're going to move this on over. I'm going to create this is going to be 30 degrees. So we're going to adjust that later on. We'll bring this one on over. There's going to be a little gap over here. And then there's going to be a little meetup point right there. And yeah, let's do something like this. I'm actually going to put this guy over here. Okay, great. So let's just think about this for a second of what I'm doing. We can just move these guys over as well. This is going to be the top portion of the safety razor. This is going to be the bottom. We're going to talk about the bottom later. Let's just focus on the top for now. There's going to be a relief over here for all of your hairs and washing everything out. And these two, the top and the bottom, are going to mate together. You're going to see this all come together. Just hang tight with us and everything will make sense. So One thing that I've noticed is a lot of these razors, this angle right here is 30 degrees. So let's press D. We're going to create an angle between those two. Let's go 30. Very good. Now let's start. Oh, we're still in dimension mode. So again, if we've pressed D in the past, we've added a dimension and then we want to do something else, make sure to hit escape. And now we can move this line. Okay, very good. So what I'd like to do is there's supposed to be a little bit of a distance in between the end of our razor and the edge of our safety razor. What's this distance supposed to be? Very small. You can go a little bit more aggressive if you want, but I'm going to press D for dimension. I'm going to put this right here, and I'm just going to call it 0.1 mils. So as soon as I do that, the line turns black because it's fully constrained. Now at this point, let's make sure that our lines are constrained. This one can still move. So in order to make this line vertical with this one, we're going to go to the vertical horizontal constraint, and we don't want to pick the line. If we pick the line, it's going to say it's over constrained. This is already vertical. You cannot change it from being vertical. That's because we've got these perpendicular constraints going on right there, but we need to pick an end point. The end point is floating. So we're going to say, I want this to be completely vertical to that point. Very good. Now we've got a couple other things that can be adjusted, but we'll worry about this in due time. Let's assume that this is going to be, well, let's go 5 mils there. And as we pull this down, you can see that our bottom grows a little bit. Let's now put our relief over here. And what I'm going to do is I would like to, oh, we've got 2 lines all of a sudden. There we go. This is constrained. If we want to delete a constraint, I don't want this 90 degrees to this line. So I'm just going to click that constraint and delete it, pressing delete on the keyboard. There we go. I would like to probably get a 2 millimeter end mill, and it's going to be machined this little pocket over here. So it's actually going to be a groove or a slot. So I'm going to go over here. If I move up 90 degrees, you'll see that there is a 90 degree perpendicular little symbol right there. So I'm going to go up, and then this is going to go back over to that line. Now let's add some constraints to this. Let's go D, and here, this messes up a lot of people. If I just go to the left, you can see that this isn't the dimension we want. We don't want a vertical dimension. It's the same thing if we move our mouse up. We don't want a horizontal dimension. We want the angular dimension. And here we're just going to move it on an angle. And this is going to be, let's go to 2.2 mils. A 2 millimeter end mill should be able to ramp down there, no problem, and clean this out on a 5-axis machine, which PCBWay can do, which is really cool. And now we want to set this in a spot that it's going to do a good job for our razor. So let's pull this up, and we're going to do something like that. Yeah, there we go. Okay, now let's create a dimension down here, and we're going to do our angle dimension again. Let's pull this on over. Let's just go to 6 mils. I don't think it needs to be deeper than that. That's pretty deep. Very good. Now we need to worry about this. So this is going to be, again, the razor is just going to be coming off the outer extremities of our top 2 components right there. But we need to worry right now, well, what still needs to be constrained? So let's move this. So our dimension right here. Let's go to, we're going to press D and click these 2 points. Let's go on an angle. And this one, I don't know, let's call it 1.4. Let's go a little bit more than that, 1.6. So we're going to try and bring this down a little bit more, 1.2. Remember, we want a little bit of relief over here. We could probably even go to 2. Very good. Excellent. So this is looking pretty good. So this is, again, the profile of our top of our safety razor. This is going to be the profile of the bottom. And this razor is actually going to be floating. And this is going to be completely a void area over here. So I think this is looking really good. Very good. And I think I want to keep this right there. We don't have to turn anything else into a construction line. We just, click on the close profiles that we want. Any of the reliefs, the fillets that we're going to put on, or the rads that we're going to put on later, we're going to do that in the 3D or the solid workspace. We're not going to do it within sketches because it has a tendency of breaking all of our constraints. So we don't want to do that. However, we do want to figure out what still needs to be constrained over here. And here we go. Yeah, if we just click on it and move it, we can see what needs to be constrained. So let's create a dimension between that and that. And I don't know, let's call it 10 degrees. Perfect. I think everything is fully constrained except for this guy right here. And I think it's it's the length. Okay. So let's just move this on over. We're going to have to make sure that this value, well, actually this doesn't really matter. Let's just call this 7.5. And I'd like this to meet up at the same spot. So remember how to do that. We're going to make sure that this is basically vertical. Make sure that we can click on our endpoint. We'll go horizontal, vertical, and by default, it's going to make those vertical. Now, everything is completely constrained. Everything is looking great. So at this point, let's go finish sketch. And if it's hard to follow here, well, we've got the rest of the tutorial that you can watch. So remember, we've got our line going down our y-axis over here that we're going to mirror to the other side. So let's extrude this. And now here's the thing. We've created the profile. We've created a master sketch. Let's go to symmetric. We just have to make this a little bit bigger than our blade. So I think what I'm going to do is call this 42 mil, make sure it's set to whole length. And we can just make sure our razor's turned on right here. The razor's a little bit smaller than it, and that's great. Sometimes what happens is this edge on the razor is actually very sharp. And sometimes razor companies out there, safety razors, they'll make this a little bit shorter. And what happens is when you're trying to screw the handle to the top, you cut your fingers on this. Obviously, you're not going to pinch your fingers from from this side and that side. You usually grabbing where the arrows are. But still, if it's not long enough, your fingers are going to get all cut up on there. So anyways, let's pull this off to 42 mil. This is looking really good. Very, very good. And in real life, the razor is not going to be extended down to there. You can see in the drawing, there's a relief. It's actually probably, well, dimension K is 2 mil. So 2 mil from here, there's going to be a little bit of a relief down there. And that's for different designs of safety razors. But yeah, this is looking really good. So let's go, okay, now instead of new body, first of all, we're going to go to new component. And let's go, okay. So this creates a new component, and right away, we can rename this our top. So why did we do that this way? Well, if we need to make changes, we can do it all within one sketch. And this is our master sketch. And we can actually rename this master sketch. And this has all of the elements for our top and bottom components within that. So that's why we've done it that way. But when we've extruded, we've created a new component. Now, if we activate top, you can see that we only have extrude in our timeline. So this is looking really good. Now let's go to, well, what else would we like to do? Here, we'd probably like to put a couple fillets on it. Oh, here we've got a little problem. You can see that our blade, this shouldn't be, there shouldn't be another face down there. And this is actually a flat face. So I'm going to hide my razor, and I actually want to delete this right there. Yeah, very good. So now we turn on our razor. There's this little bit of relief. Now at this point, what I'd like to do is I am going to delete this face as well. And now I'm going to put a fillet over here. Very, very, very good. So when everything's said and done, remember our other part of our safety razor is going to be, let me just go to our side here. This is going to be extending just a little bit past it. So maybe this fillet right here is a little bit too much. Maybe The razor itself is a little bit too far, but I like mine aggressive, and I think this is going to be fine. Again, we'll see when I actually shave myself. Yeah, how much I'll get cut up or not. Hopefully not too bad. But anyways, let's go create. Oh, instead of creating another fillet, I'm going to go back to this fillet in our timeline. Let's just hide our razor over here and our sketch, master sketch. And we're going to create another selection set. And I'm going to make this into a nice, there we go. Let's call it 8. I don't know. 8 looks pretty cool. Now let's go back to 7. Okay. Very good. So I'm trying to think about the manufacturing of this as well. If we start adding too many fillets and everything, it's going to probably be too expensive. So I'm going to keep it with this shape. Now let's go to a mirror. And I'm going to select this, making sure that top is activated. Our mirror plane is going to be right there. We're going to join the two together. So now we've got our top, and this is looking great. This is looking really good. Let's keep on going with the process here. So as we look at our drawing, we have all the specs that we need to work with. What I'm going to do is I'm going to create some elongated posts to hold our razor. But on this side, on the top, these are going to be the slots, and the posts from the bottom are going to fit within them. Again, you'll see the design intent later on as we create this. But what I'm going to do is, well, let's create a sketch down here. We can orient it so it's a little bit easier to work with. We're going to create this circle as something. There's going to be a post coming out here or a pin, and it's going to kind of center our razor blade. Now, we don't want this to be an exact dimension, but I'm going to call this 4.41. There we go. And in our drawing later on, we're going to specify that this is going to be, oh, this is interesting. Ah, it's that way because it's oriented that way. Yeah, that's fine. Okay, so 4.41. And now let's create our slots as well. So here, why don't we create a center? We can, you know, some really try and get it right on our x-axis right there. And again, this is our sketch axis, not our model axis. So we're going to move this over. Let's create a dimension here, and we're going to call this, yeah, let's call it 1.04. And again, this is going to be the slot. A pin's going to fit into this from the bottom section. And this isn't the dimension that we want, 1.04. We want the half dimension to be 1.04. So let's just delete that. We're going to press D for dimension, and we've got a construction line that Fusion puts in. We're just going to create that one and that one. And this is going to be 1.04. We're going to have dimensions on this. You're going to see what that looks like in a little bit. And we want to create at this point, based on our drawing, we're going to create a dimension. Again, I'm pressing D for dimension, and I'd like to create it from the outside edge. Now, if I'm going to click the outside edge here, look at where the dimension goes to. It goes to our center point. So I don't want that. D for dimension. Let's pick our center. Right click. We're going to pick circle arc tangent and pick the outside there. And let's now call this 17.45 right there. Now, what else needs to be constrained? Let's move it. So as you remember, as we pick any entity, we can move it and we can see what needs to be constrained. So, and actually look at now our dimension went to the wrong side of our tangency. So I need to delete that. Let's just anchor this. First of all, I'm going to make this line horizontal to our center point. So let's pick that. Boom, boom. Very good. Now this can only move left and right. So let's press D for dimension. There we go. Right click, pick circle arc tangent, pick the outside there. All right, now we're getting somewhere. 17.5. And I'm just going to specify this as, let's go 10 mils right there. So everything's black. Everything is the way we like it. Excellent. You can see dimension is still active, so I have to press escape. Let's mirror our slot here. And remember, we don't have to pick all of our different entities, we can just double click and it picks all of the chained entities. Our mirror line, there's no mirror line right here. So we could create a line, but basing everything on the origin, we could just, in fact, turn on our origin, and then we can pick our line right there, our y-axis in this instance. So there we go. Okay, so now everything is mirrored. Everything is looking great. We can extrude this down. Perfect. And I don't know, let's go 1.5 mils there. Okay, so those are our slots. We don't have to go that far actually, but that's okay. I kind of like that. If there is gunk and everything from shaving that get in there, you probably just have to use a toothbrush or something and brush it on out of there. Right at this point, I'm not going to put chamfers. And the reason is usually with drawings, when we get our technical drawing later on, we're going to specify on that those are going to have a chamfer. When we put a chamfer in the 3D model, it complicates things. So my theory is when the chamfer is quite small, leave them out specified in the drawing, especially if it's just a broken edge or something like that. Otherwise, if it's quite big, then you can specify the size itself in the 3D model. Anyways, let's go back to our sketch here. We need to extrude our pin. So we're going to go there and we're going to extrude it. You can see we picked that axis as our mirror axis, and it's created this line for us anyways. So some people ask, well, why do you put in a mirror line when it's not necessary? Well, Fusion does it for you anyways. So yeah, anyways. So here we're going to extend this post, and I'm just going to wrap around over here. How far does this post need to be? Well, let's turn on our master sketch, and we can see our line right here. Now we don't want to go past the bottom, which is the bottom of our bottom piece right there, our body. We want to go somewhere in between. This is going to mate with a hole on our body piece over here. So we want to just go at least a little bit. The farther we go, the stronger it's going to be. So, you know what, maybe we could go to 5 mils. That sounds pretty good. We're going to go join. And then what we're going to do, let's create another sketch. I'm going to hide that master sketch there. Let's create something over here. And this is going to be the size of our thread. So 4.5 mil is... Uh-oh, maybe I didn't specify an actual dimension. I don't think we did. Oh, there we go, 4.41. So, yeah, so 4.41 max is going to be the size. Okay, so down here, instead of 4.5 mil for our thread, we're going to turn this to a 4 millimeter thread. Perfect. And now we can extrude this. Let's bring this on down. And I don't know, let's go to a full 10 mils right there. So let's hide our sketches. Now we're almost done this top portion. All we need to do is add a thread. And we're going to do it right there. It should bring up a 4 mil right there. Yeah, everything's looking good. So anyways, this looks like the top of our safety razor is done. The bottom, of course, once we highlight that, we can extrude this bottom, create a new component, and then we're going to create a handle on the very bottom down here. But we're going to do this in stages. Again, we'd like to see this kind of take place over a few weeks. So how do we go about ordering this particular part? Well, we're going to have to create a drawing for it. So let's just go save. And let's get into our drawing workspace. So there we go, from design. And yeah, let's just do that as well. We could go to ASME. I think I like ASME a little bit better. We're going to go OK. So as we click on that, you can see that we're going to have to place our piece somewhere. Let's see here. Yeah, we can orient it this way. That's fine. But I'd like the scale to be a little bit bigger. Right now it's small, so 2:1. Yeah, we could probably even go 3:1. There we go. Yeah, make it nice and big. Perfect. We're going to go visible and hidden edges. Let's go OK. Okay, so one of the reasons why I like the ASME a little bit more is the orientation of the dimensions as you draw them. But let's just get this underway. First of all, we're going to create a projected view. Let's grab this and, oh no, do you know what? We should have done this the opposite way. Okay, so instead of our front, let's go to our right view. There we go. And let's go close. So now as we, adjust our projected views over here, we're going to go up and down and to the right. Let's do that. And then we can add an ISO view up there. They're all going to turn to the hidden line function, but I'd like to single click that and turn this into shaded so that this is what the shaded portion is going to look like. So the file that we need to send to PCBWay is a step file. So most of these dimensions are going to be specified in the step file, and they're going to work with that. However, we need to make sure that our slots and our pin and the thread information is all easily understood for the machinist so that they can understand our design intent and make sure that this piece is correctly manufactured. So I think that these are actually a little bit too big. So I'm going to double click. I'm going to turn this into 2:1 scale. There we go. And at this point, I am going to, let's pull this all up here. And I am going to create a detailed view right here. And I just like to, maybe pull this off to the side, detail A, and that's 3:1. Let's go OK. Very good. Just to add a little bit more visibility to see what's going on here. So first of all, let's create a text on our edge, and this is going to be an M4 by 0.76G thread. Excellent. That's a good thing about creating a thread. If we create a note based on a thread that's modeled, and we don't even need to do a model, we can do, or the cosmetic model, we can just do the standard, which you can see it's actually not fully modeled here. It's just like a skin that's put on it, but it shows that it's actually a thread. But what I want to make sure is that this is a full number of threads for that distance. So what I'm going to do is I'm going to create, well, let's create another note on this side, and I'm going to do it over there. We can just go OK. But instead of this spec right there, I'm just going to delete all of it. There we go. And say something like this, 10 minimum full thread. Okay. So this is saying that the minimum distance of thread is has to be at least 10 mils. And this over here is our actual thread specification. But now we need to get to our, oh, and you can see our detail over here is a little bit low. Let's just move this over so it's not interrupting everything there. Perfect. I can move our detail down a little bit. Okay, so now let's zoom in over here. This is where we're going to have to put some more details. So first of all, we're going to create a center mark right there, and we're going to create a center line with our slot. Now, let's create some dimensions. First of all, we need a datum identifier, and our first datum is going to be put right here. Let's do this, and we're going to move our, let's click right there. So this is going to be datum A, and we could put a bunch of GD and T over here, but it's not necessarily always needed. If there's an engineer out there and they're just stewing right now, you love GD and T and you're trying to, if you want to let me know how bad I've done this, please feel free to let me know. But for the majority of cases, this should be easily understood by a machinist, especially when they have a step file. But basically, we want to make sure that our datum of our pin and our datum of our slot are the same. Now, I guess I could have put the datum A over here on our pin, but regardless, it should be easily understood. So now I'm going to go D for dimension. We're going to create our dimension right there. And I'm actually going to create another dimension between those two. Very good. Now let's add some tolerances over here. We have to make sure that our components actually mate together. So let's move that on over. We're going to double click. We're going to click on tolerances, and this is going to have a symmetrical tolerance of 0.01 mils up and down. So the high is going to be 1.05, the low is going to be 1.03, and that will mate with the other side of our of the bottom of our safety razor. Very good. And we're going to put a tolerance over here as well. And instead of 2.08, this is going to be symmetrical, but I'm going to open it up a little bit. This is 2 times this value, which is good. Very good. Now, we're also going to create a dimension based off of our pin right here, 4.41. And this is simply going to be a maximum tolerance. So with PCBWay, there is a bunch of, they've got an ISO standard for what they work with. And we're just going to say max here because the standard that they work with, there's going to be a particular dimension that they're going to work within. This is going to be, I think it's 0.1, the tolerance is 0.1 mils, but we just want to say we don't want it over 4.41. There we go. And that's how we do it. We're going to say that this is going to be 4.41 max. It cannot be bigger than that. But right now, our technical drawing is pretty well done. Let's just organize it a little bit. A little bit difficult to move things around. But anyways, there we go. So let's just rename our project as well. I could make this all fancy and everything, but I'm just going to rename this project to our safety razor assembly. Very good. And our title is going to be our top drawing number. Now we can just name this whatever we want. I'm just going to call it Safety Razor 001. Very good. Drawn by Ty on June the 29th. This is all looking really good. So make sure to press enter. That's going to lock it in, finish properties. So now as we duplicate our page for the following or the next components, it's going to keep our title block here just the same, and we can just adjust it from there. So this is our top. Our top is done, and now we can move on to our base. Now before that, let's just order this up and get it and show you what it looks like. So let's save this first of all. I'm going to save that right there. We're going to go back to our safety razor assembly. Now under body, we could actually do it under bodies, or we can do it under a top, but we're going to right click. Let's go export. And we are going to save this as a step file. I'm going to save it to the desktop. Let's go export. Now let's load up PCBWay. So here we go, PCBWay. We're going to go to CNC 3D printing. We're going to click on that. And now it says drag and drop or select your file. So I'm just going to drag and drop top right there. And now we've got to add a quantity. Let's go 1. We're going to keep it under metric right there. Now I'm going to do brass. I would love to do stainless steel, copper, titanium. By the way, if this works out, if it looks really good and it cuts really well, if you'd like to order this, just look in the description. If I've got them available to order, I'd love to get a ton of these. Maybe ones can pre-order it. And anyways, if it is in the description and you can order one, I hope to have one in stainless, brass, titanium. That would be really cool. Carbon fiber as well. All of this is pretty neat. Surface finish. Let's go here and we're going to go bead blast. Now technical drawings. We're going to have to upload a technical drawing. Before we do that, we've got to go back to our drawing over here. We're going to go export PDF. We're going to export all sheets because there's only one. And this is going to be our top drawing. Very good. Let's go save. Now we can go back to our PCBWay and we can upload a technical drawing. This is going to be under desktop, top drawing. Very good. So do your parts need to tap threads? Yes. And it says here, if you do, you'll need to have a technical drawing, which we already do. If I didn't upload it, it would bring up an alarm saying, oh, you need a technical drawing. Anyways, there we go. We don't have any inserts, tighter tolerances. Yes, we have a couple tight tolerances of 0.02. Actually, our custom, I believe, is 0.01. So we're going to do that, 0.01. Oh boy. Enter custom 0.01. 0.01. Okay, let's go confirm. Very good. Anything else that we need to do over here? No. All right, so what we're going to do is let's just go to get a quote. Now as we go into our cart and order it, it's just as simple as that. So let's see what the final product looked like. So if you've appreciated anything you've learned, if you've learned a new skill or a new technique, or if you just like these tutorials, please consider subscribing. You can even become a member. Ones can become Patreon members or YouTube members. You could buy us a coffee too. Any little things like that you can do to support our channel, we would just thoroughly appreciate it. And we thank you so much for your ongoing support.